anyone, firstly, I'll give the word to you.
Yeah, thank you very much. This is our partner session number 8, and as Daniel mentioned, this is on analytics, informatics, and data. So how do we use these tools, products, in order to improve water security and climate change? So basically it's a very broad topic in terms of how these tools and technology can help us. This is this session is designed for about 75 minutes, but based on our experience yesterday, we would try to keep it 70 minutes so that we have the following session also starting in time. So we have 4 presentations. So we'll spend about 40 to 45 minutes for those 4 presentations. We are then left with about 20 minutes of panel discussions, and Professor Idel Gunther will join also as a 5th panelist, and that would take about 20 minutes or so. And towards the end, my colleague Professor Daniel Carthe will try to summarize in about 1 to 2 minutes the major learning and output of this session. And during this panel discussions also, we would try to encourage our participants to contribute to those discussions. So this is how we have designed this. And let me give mic to Professor Carthe to invite the first speaker.
So thank you very much, Professor Babel, firstly for organizing this very good conference, for offering us the opportunity to organize a partner session. I would now like to introduce my colleague, Professor Kaveh Madani, who will deliver a keynote on analytics, informatics, and data for sustainable water management. Kaveh is the head of program for Resource Nexus 8, or Analytics, Informatics, Data, at United Nations University Institute for Integrated Management of Material Fluxes and of Resources, or UNIFLORES. And he is the designated director of UNIO-INVE, the Institute for Water, Environment and Health in Ontario, Canada. He holds a Bachelor of Science in Civil and Hydraulic Engineering from Iran, a Master of Science on Water Resources Management from Sweden. He obtained his PhD in Civil and Environmental Engineering at the University of California in Davis, and is a globally recognized environmental scientist, educator, and activist. His work focuses on complex human environment systems, and in the past he held or still holds professorships at the City University of New York, at Yale University, and Imperial College London. But he also served as the Minister of Energy of Iran and the lead of UN Environment Assembly. Let us now all welcome Kaveh Madani for his keynote speech.
For the generous introduction, Professor Carthe. Greeting, Professor Babel. Thanks for having me here. As you said, the topic is very broad, so that would be also the case of my presentation. It's mostly food for thought, an introduction of the activities that we are having at UNIFLORES, and an initiative that is supposed to be inclusive and bring all of our expertise together. So I hope those who have tuned in or are there would use this opportunity also to learn about our program, and also help us with developing this program further and further, and helping with its success. So essentially, as the title says analytics, informatics, and data. What brings to this era of human development is something that we are talking about these days a lot, and in the field of water resources also, we are trying to figure out how we can use these tools for better management of systems. But what systems are we talking about? Systems that are very, very complex. And as we learn more about them, we realize how much we don't know about them and how hard it is to solve and address the problems that we are dealing with. Essentially, as a water engineer, water resources student early on in my hydraulics class, fluid dynamics class, the engineers, the professors in engineering told me that water always flows toward gravity, by gravity, from a higher elevation to a lower elevation. I then took economics courses during my PhD and did some work in my postdoc on water resources economics and policy. And I realized that I was told that we only do things if they're economically justified. And later I entered the political world as the deputy head of Iran's Department of Environment and learned that we do a lot of things that violate both the physical and engineering laws and the economics laws. A good example of this is the state of California, where water actually is pumped upstream, and people have not been able to stop it. It goes toward money and it goes against gravity, and it's not probably economically justified in many senses, and it damages the environment. But the politics of water is very complex. In the Middle East, where I come from, many people expect more and more tensions around water, and we are hearing this about also other parts of the world, not only in the Middle East. So when Aristotle said, talked about systems being greater than the sum of the parts, he meant it in a positive way. Here I mean it in a cynical way, and I think we need to do more and more to try complex human water systems. We have with this system career is that we are dealing with systems that have some essential characteristics: bounded rationality. We have a causal dynamic relationship between the elements. The uncertainty is very limited. It's very hard to predict and project actually the future of these systems, and we are seeing evolutionary changes both in the natural and human components. And these systems are also talking about their investment might not necessarily be a good reflection of what can happen in the future. And that is why a lot of our infrastructure are failing, no matter what sort of probability distribution we have used to design our infrastructure. But when I enter the political world, and as I learn more and more about water and human systems, I realize that water is only one of the many components of larger systems that involve other elements. We talk about water, food, energy nexus, a lot of us, because once you touch water, you realize that you have to also care about the agricultural sector, the energy sector, the environment, and so on. But the reality is that we are dealing with a much larger system of systems, which has other components like economy, employment, public infrastructure, defense, and what we have learned really a lot of lessons about the health sector during the pandemic, how these systems are interrelated and how they are one of the systems can result in changes in other systems and feedbacks to the origin, and it's hard to deal with. That's the sad part of the game, because we are told by the complexity science experts and systems experts that problems of this kind will never have a solution. So there is no way that we can fully solve the water problems today, tomorrow, as we know, it was not possible to solve them completely in the past. Their forms, their boundaries, their conditions would change, but we can never solve them. So as long as humans are on this planet, and perhaps other species, water management issues would be with us. But once we develop this understanding, we've got to realize that we can still address the problem. We can still define boundaries for our problems, and come up with problem definitions within the large systems and try to address them. That's what to do. As no matter how complex our system is, no matter how our understanding of the world is changing, we're counting on our abilities and our brains. We think we are smart, and we are smart indeed, and that's how we have been able to survive so long. We might not be as smart as we think, but at this point in history, at least, we are seeing what we call the fourth industrial revolution. The fourth industrial revolution, which has changed many, many things, including bringing this capacity of communication. So I didn't have to travel all the way to Thailand, but still have the pleasure of interacting and being with you. So we also have the unprecedented capacity of intelligence. Algorithms are doing a lot. We can mine data, we can deal with a lot of data, and we can collect a lot of data. I mean, sometimes too much. This unprecedented capacity is supposedly giving us the chance of understanding and navigating through our systems. But wait a minute, we might not be as smart as we think. And the question is whether measuring data and collecting data would automatically result in a better understanding of systems, because many times we might get the correlations wrong. Indeed, this is the problem with having so much data but not enough understanding of the system. So you only succeed in managing these systems if you combine the two expertise, collecting data with the knowledge of the domain. That is why computer scientists can bring a lot of valuable things to the table, but they cannot on their own solve water management problems. They still need the domain expertise, because there's many times our history of development, what we thought would be right was turned out to be wrong, or at least had some unintended consequences down the road. And we have seen this with the previous industrial revolutions. We see this with the we also what we are doing today. So there would be consequences down the road. Now, what are we doing about this at UNU Flores, at the University of the United Nations, the academic arm of the United Nations, tasked with helping the researcher community, but also the policy community and of course society. We understand that there is this gap. We need to navigate through complexity. So UNU Flores, the institute that is developing and promoting the Nexus approach to sustainable development of natural resources, of environmental resources, it is trying to also equip the world with the data component, or the aid tools that can be helpful in navigating through this complexity, into helping us understand the interrelated dynamics and interdependencies of these systems that we are dealing with. We're talking about also the SDGs and delivering on the goals by 2030. And as we know, all those goals are interdependent and interrelated. If we want to help the world get there, we have to equip them with the right tools. And that is why we have developed this new program at UNU floor. It's called Resource Nexus 8. 8 stands for Analytics, Informatics, and Data to enable the Resource Nexus approach to sustainable development. Now, this is much easier said than done, but you know, that's why we need to do this together. Now, who are we trying to help, and who you know, whose contribution is needed here? We are a firm believer in the fact that that this is a triangle. It's, you know, science, policy, society getting together, trying to, you know, trying to help this. So we need all the components if we want to succeed, and this is what UN has been consistently actually promoting. So we need the academics, business, and professionals to be part of the game as well. We need the policymakers and UN circles to be with us, and as well the general public, you know, at some point to join us in helping us with citizen science and collecting data, monitoring, and so on. Now, the program has three components: the data pillar, which is trying to create a repository of what is out there in the data world. But what we are doing differently from others probably is that we don't collect data for the sake of collecting data. You know, this is what we have seen. We have, I talked to some policymakers and some managers and saying that we have a lot of data that we don't know what to do with. And indeed, sometimes we have some data at some resolution that is, you know, at least at this point in time is not needed. We don't know what to do with that sort of data. So it becomes you know, a questionable issue. Like, you know, what are we trying to do with data? So we are trying to develop a problem-driven approach. We collect the data for the problem that we are trying to solve. Now, that problem can be dealing with the drought or a flood, or monitoring and assessing. I know you and SCAP colleagues were there, at least yesterday. We had the pleasure of doing a lot of work with them on this particular problem, soil health and another issue, but problems can be also regional, problems of the Mekong River Basin or the Nile River Basin and so on. So that is what we put at the center. Then we remind people that there is a need for a nexus approach to the problem solving, and if you want to adopt a nexus approach, then you have to do a multivariate analysis, and you have to have different variables monitored. Now, informatics is of course needed because the process of converting data to wisdom, to information, is also a complex one, and just collecting data would not be sufficient. As well, we need the analytics component for that matter. So not only we need to collect data, you know, deal with data, process the data, but also have and develop tools that extract the useful information out of the data that we are collecting. So at the beginning, we thought that these pillars can be separated, but you know, we go into the program and we realize that you know, these are also very interrelated. What our colleagues have done around the world is a mix of all these tools, all these components together. So what we are doing right now is that we talk to different groups, different colleagues around the world who have done work related to these different problems. We pick a problem, we bring a working group together and ask them as the expert of that problem actually to help us find the best, most reliable, peer-reviewed aid tools that can be used by those by the users to address a problem in that domain. So we have so far developed a few of those in the drought area, in the soil health area, wildfires, and we are in the process. You know, we have also had progress with infrastructure resilience as another component, and we are increasingly in you know, searching for people who can help us develop other modules, actually, other working groups for us. So we combine, you know, these groups that we are shaping would have players and collaborators from the UN system and from the scientific and professional community. And together, we're hoping that these groups can can change the way we approach these problems. And instead of redoing things and reinventing the wheels, we are distributing our, counting on a distributed effort across the global network where people share what they have done, because, we might not need to, all of us like to redo the things. We just have to find out who has done things around the world. And in this program, our approach is to bring the Global South expertise also and promote the Global South expertise, because often in the Global North, we don't understand the good quality of the work, or they don't appreciate the good quality work being done in other parts of the world. So if you are doing things related to this program, please approach us and please let us know, and we can figure out together what sort of new modules we can shape. Thank you.
So thank you very much, Kavi, for setting the scene for this session by delivering your keynote on analytics, informatics, and data for water sustainability. And we would have time for questions, and that includes those who have joined us online at the end of the session. We would now directly continue with a series of 3 more presentations. And the first speaker that I would like to invite to the stage now is Professor Hyungjun Kim, who leads the hydroclimatology lab at KAIST, that is Korea Advanced Institute of Science and Technology, who is a professor at the Moonseol Graduate School of Future Strategy and the Department of Civil and Environmental Engineering of KAIST. He received his PhD from the University of Tokyo, Japan, where he worked under Professor Taikan Oki, who will be one of the high-level panelists here, but also moderated the previous keynote session. Hyungjun Kim in 2018 was awarded a Top Author Award by American Geophysical Union, and since 2020 alone he published 41 papers on water security and climate change, including 8 in Nature and Science journals. And that's a very impressive record. Personally, I'm very grateful to collaborate with Hyungjun Kim and Taikan Oki in a small DAAD-funded project, but would now like to invite Professor Kim to his speech titled Climate Crisis and Meta-Earth Technology, which will really look at the forefront of science in this field. 5 to 6 minutes, if possible. Thank you.
Okay, and then I should run. Okay, well, thank you. Okay, so we all know this climate strife, and then we are scientists. If we project in the different axes, it goes like this, right? I will run, really. And the problem in, I think we are talking a lot about the aspect of adaptation now, because we are doing mitigation together, but adaptation should be done by different regions. And then this is the finding from IPCC 6, the published last year, the working group 1, and we kind of used unequivocal. It means we are really not sure the climate change has been occurred because of the human being. And we all know, this very famous photo, name is Blue Marble, taken by Apollo 17 at 1972. And we cannot see any evidence of the Anthropocene here, right? Just there are a lot of waters. Like blue is water and then white is water too. But what if we see this photo at the nighttime, and then we see there are a lot of the light. And the left side is Anthropocene Earth, and the other side is Pristine Earth. And because of the generation of the energy, we emitting a lot of greenhouse gases, right? And then this is the evidence. And then okay, so what if? So there is the change, differences between with human impact and without human impact. There is a very clear difference of the warming signal. And now we can do the experiment with and without human impact. And traditionally we have used global climate model, or general circulation model, or Earth system model. And now our simulation technology has improved a lot. And right side of the image is satellite observation, and left side is digital twin. It is reproducing the computer simulations, and then we can see seamlessness of the simulation and reality is reduced significantly now. And now I suggest the term Meta Earth here, because now the quality of the reproduction of the Earth system is pretty much high to be applied to address the real questions from society. Okay, and then this is all very important, and we know a couple weeks ago there was a COP27 in Egypt, and then one of the most important agenda agreed there was loss and damage. And of course, if we look into the detail of the agreement, we cannot find the liability and the compensation, the term itself. But actually, I think this is a big step forward to the liability and compensation of the damage and losses by climate extremes induced by human-induced like global warming. Okay, this is also very famous, right? And PDF shift to right side, and then larger variance. And then there is additional risk which can be converted into monetary unit. That's damage. And then so now we should quantify how much damage and the monetary unit was added because of human-induced global warming, and then we could answer about how we are responsible on the additional intensity or additional damage or something like that. And this is so I will show 3 examples recently I published in this year about the drought is, so when the abnormal becomes normal, and so the worst drought in previous 141 years, and it will occur again at some time, and then but it goes worse and worse, and it will be very normal. Like once in a century drought will occur every year. When it's gonna come? And of course, we have very high spatial heterogeneity for different regions, and also for different scenarios. And then like a Mediterranean area, and then the South America will suffer those kind of abnormal to normal, we call it the new normal, in a very early stage, like 2030 or something like that. And the other places also will meet those kind of things in different timing. And another big concern in East Asia is typhoon, and especially this year, Korea was attacked by very strong the typhoon, which is named Hinnamno. And we also try to answer these kind of questions. Does global warming make a typhoon heavy rainfall more frequent? Yeah, maybe. So we generated we generated Meta Earth without human impact. This is all 100. The white lines are without human impact, and then if we overlaid, okay. So if we overlaid, actual the Earth, the changes, which means including human impact, it exceeds natural variability from 1970 and very rapidly. I think we can say this is another tipping point about the increase of the typhoon-induced heavy rainfall at the East Asia. And of course, okay, yeah. So we used optimal fingerprint analysis to extract Anthropocene fingerprint, and we see the changes of the increase of the typhoon heavy rainfall is very unrealistic when we do not consider human impact. And I will skip about the details of science. And the other one would be, so we all know about there are the investment required to mitigate, actually adaptation, but mitigate the local disaster is really huge. So we should make those investments very efficient. But if we have the projection with a very high uncertainty, it's very difficult, right? So if we have the weather forecast tomorrow, but if the precipitation the probability 50%, it's really kind of, information is very hard to interpret. And then our projection sometimes goes like that. So we try to reduce the uncertainty And so how can we reduce the prediction uncertainty? Let's say this is x-axis is time and y-axis is uncertainty, and we try to the range of the uncertainty. And the idea is very simple. And there are the meta-Earth like that. Okay. There are many GSM simulations, and if we project into the one axis, it goes to uncertainty. And then this uncertainty can be reduced if we just pick the GSM simulations which shows the high forecast skill, and it means if we get rid of the worse simulations, the future projection uncertainty, which is a spread, is going smaller. Yeah. Okay, I think this is my last slide. We all know this is the state-of-the-art framework, how we to the project, the future. So we see the pathways. So there is, with things, sectors, and then those sectors are interpreted as the kind of boundary condition, like a so-called scenario, to run integrated assessment model, and the integrated assessment model calculate emissions turned into energy term, and then that is introduced to the climate model, and the climate model reproduce the Earth, and then we couple, or with the loose couple, the simulation using impact model, we calculate disasters or some impact assessment of impact for a lot of impact sectors, and then it goes back, and that is completely circleable. As you know, we do not have this link. This link is still missing, and of course, we are starting to incorporate this one into the physical modeling things, but we just started. Okay, so to do that, we should build some sort of the equation, and then maybe that equation consists of the processes is natural processes maybe, and then players, ourselves, and then strategy, how to optimize or how to we do the right things, and then those kind of things will fill the last gap between the human society and then natural systems. Okay, thank you.
Thank you very much.
So thank you for your excellent presentation, and I would now hand over the microphone to Professor Babel, who would introduce the next two speakers.
Thank you very much. Without wasting a minute, because we have only 20 minutes for this session, we must stop at 4:20. So I would request Dr. Gerald, who is the associate professor and senior researcher at UNIHE in Netherlands, to please make your presentation in about 5 minutes, please. We are really time pressed,
Nice
because
challenge.
yesterday's experience was not good.
Hello.
And I don't want to delay the things today.
Yeah, don't worry.
Yeah,
But in
thank you.
fact, based on the timing, I will really rush into my slides. I wanted to just give, we are talking about technology, we are talking about data analytics, we are talking about, in this case, artificial intelligence, and one of the areas which I have been working is chatbots or AI chatbots. And this is a work that we have done with a couple of MSc and PhD students. And it's just to spark ideas on what will be the future of information systems. And to do that, probably, I wanted just to highlight the two things. One, the large amount of information that we have right now in social media, internet, and so on, and how this is, let's say, a big source of information that we need to start to take into account. There are a lot of technologies there, and what we aim at is combining that large amount of data into systems like this one. I wanted to show a video where you see the Jarvis. Yep. Seconds. Yeah. You need to jump. Well, what you are seeing here is a sketch of the Iron Man movie, Marvel Studios, and so on.
currently vacuum-formed digital wireframe. I need a manipulable projection.
What he's saying, he's asking the system to make a scan of a whole city.
1974, Stark Expo model scan
from
complete.
sketch. And he
How
starts to look at it from different points of view.
Am I to include the Belgian waffle
Raises up
stands?
and
That
asks
was rhetorical, just
his
show me.
assistant for more and more information to try to see it from different perspectives. So let's say
The
end up
Belgian
the video.
waffle stands.
Yeah, and let's this one. So what we want to do, or we have been aiming with the students, is to try to use this technology for flood risk, flood analysis, flood forecasting, and flood warning. And in all these areas, we see situations like what you see in this video. This was this year, where parts of a city get flooded in a very, very fast time. And what we want is maybe the assistance in your mobile phones, maybe the assistance in a website can start to provide you interactive information from your models. And that's what we did. What we started to go is to build these models where we look into space-time variations, the hydrodynamics of the systems. We try to come up with different types of solutions. And what we go is into the following. Having questions, so how can we provide warning to people in flood situations using this technology? How to provide automatic dynamic information that can report our we receive reports from the governments that are quite large, and how can we synthesize this? And the last one was to create, so how can we build chatbots that can help us to extract information in real time from modeling systems according to the profile of the user. If it's a highly technical person, well, we can ask different type of things. If it's a simple person, we'll ask other type of things. Well, just going fast. The first one was example in Nigeria, where we took the national flood warning for all the citizens. We built a mobile phone app that directly connected to an information system that was helping the people to understand what the government is telling them. That was the first one. Well, here is all the technology and so on. Well, I don't think I need to go into the AI component. And the second one is the use of, in Vietnam, in the Dolo district in Hanoi. What we built was a website where we have an interactive chat system that goes into a modeling system that is PC Swim, and what we wanted was the people to be able to ask the question that if with the current forecast of rainfall, which streets were going to get flooded, and such that they will change their path or the way where they were doing. So this is more of the schematization of where we build the machine learning to provide very fast replicas of the patterns. And yeah, more or less the concept of the artificial intelligence, the type of questions that we put in the bot, and the schematization of the website that is in Google Cloud. So thank you very much. Yeah, sorry that you have to go so fast.
Thank you, Gerald. Thank you very much. We will be now requesting Dr. Alex, who is joining us online. Alex, are you online? We cannot hear you yet.
You cannot hear me?
Yes, we can hear you now. Alex is managing director of Murphy, and Murphy stands for Mekong Region Futures Institute, located in Bangkok, and he has been working on sustainable development and climate adaptation for over 20 years, and his background is in complexity science, and he's going to tell us something what this complexity mean in terms of analyzing Naxos. So Alex, over to you for 5 minutes. Thank you.
Thanks, Barbara. I hope you can hear me. First of all, thanks for having me. Sorry that this time I cannot be with you personally in Bangkok. Yeah, so can I have the first slide, please? Considering that you invited me to talk about sort of the analytics of water security, I casted it a little bit wider and didn't want to just talk about the water security dimension, but really because it's so inherently connected to energy and food security, I wanted to talk about the nexus. Am I showing the slides from my side? I can do that naturally, obviously, because I don't see them in here. So let me do this. I hope you can see this. This is a very full slide, and can you see the slides?
Just a second.
Okay, so and I think Kaveh already sort of laid the ground for talking about the nexus. The big question he raised, and I wanted to connect to that, is that there's so much complexity in the system, and we need to advise policies, develop sustainable policies. For navigating this complexity, he said we need the right tools. So we were very fortunate to, actually we ran the first Nexus assessment worldwide. It was in the lower Mekong Basin, so that started about 15 years ago. And since we have ran quite a few different Nexus assessments. And we tested different tools, different methodologies. And here there's sort of a range, a gradient that I put up. On the left side, you see rapid Nexus assessments that are typically used to develop sort of system diagrams, system maps. Then it moves over multi-criteria analysis-based approaches to interdisciplinary models. So interdisciplinary modeling, meaning that you have sort of hydrological models, agricultural models, and so on next to each other. And then on the right side, integrated modeling approaches, sort of similar to what Hyun Jun was mentioning in terms of integrated assessment models and simulation models. So we worked with all of them, and we sort of tried to understand what are the pros and cons of these. And you see that in terms of the degree of complexity that you can consider with these different methods, you really move from very low to high on the right, from the left to the right. But as you move methodologically in terms of tools from the left to the right, also your costs, the data requirements are both increasing, and also the difficulty to communicate results is increasing in terms of policy. And I don't have the time to go into the details here, but in this gradient that I'm trying to open here, there's a very interesting policy conundrum, and that is that more realistic we want to be, the more difficult it becomes. But so on one side, we need to be very realistic and sort of correct with our assessments to be relevant. But the more policy relevant we become, the harder it is to actually have policy impact. And it's very difficult to explain this, obviously, in 4 minutes. But at the core of it is that the more complex our methodologies are, the more likely it is that we have unintended side effects we show. And that is often something that policymakers don't want to, or are very, it's very difficult for them to follow them. And that's why it is so difficult to have policy impact with highly complex methodologies. So that's my first point I want to make, the policy conundrum. Now, what are the strategies to actually manage this gradient, this complexity gradient, and overcome this conundrum? The first one is, and I try to really breeze through this, is to work with multiple methods. So over the past 15 years working on the Nexus, we have really learned that we need to start with very simple methods in a project, in a process, and then move more and more to the right, more and more, including more and more or higher complexity. The second is that we developed really effective participatory processes and, for instance, to engage from the beginning with some of these key line ministries to include and really make those champions, these cross-sector coordinating agencies like Ministry of Planning and Investment, Ministry of finance. Then also to establish something like a cross-sector benchmark. Like we work a lot with visioning because it's so critical to align the mandates of multiple line ministries into one direction. Then obviously to accompany these, method and process focused aspects with capacity building. And that includes typically people, technical staff in government agencies, but also academic institutions. Obviously, I can't go into any detail here. If you have any questions about the policy conundrum and strategies to overcome them, I really could just sort of glance at them, send me an email. This was really just sort of an attempt to share some of the key insights we made over the past 15 years or 20 years. Thank you so much. Thanks for having me.
Yeah, Alex, you will be part of the panel discussion, so you can still contribute to that discussion part. Yeah.
So we would now start with the panel discussion, for which we have to start it, prepared questions that we would ask to specific panelists. And one person has joined us on the panel, Professor Edeltraud Günther, who is the director of New Flores. And as she has not spoken yet, the first question would go to her. And when thinking maybe of the presentations that we heard in this session, how do you think that Nexus approaches, which are also one of the themes of the WSCC conference this year, help to advance water security and climate adaptation?
Thank you so much for having me. Can you hear me?
We can hear you clearly.
That's great. So I think some of the topics were already mentioned. So what I think is crucial is to bring scholars of different disciplines together and to connect to policymakers. So less the scientific part of the Nexus, but really the use part of the Nexus, I think is a huge challenge. And my own background is in business research. And there we always differentiate between designing instruments, assessments, and between using them. So I see a crucial issue in the use, and that means also in the interpretation of data. We really need to educate policymakers, but also scholars from different disciplines to use the data, to work with the data, to interpret the data. And this also includes the long-term perspective. This is one point. And the other is also the combination of quantitative and qualitative data. Very often I observe as a social scientist some reluctancy from natural scientists when we work with qualitative data. It's less clear, it's fuzzy, but I think this is the way to go. Otherwise, we restrict our thinking. Last comment, there is a good paper from the end of the 50s from Miller, the magic number 7, that you can only process 7 indicators with your brain. And yes, we have developed over the years, but I still think 7 different indicators are a big challenge for decision making. And therefore we have to simplify on the one side, but also to educate people in using what we have.
Thank you very much, Edel. And the second question would go to Kavi Madani. So, Kavi, based on your experience, what are the most common data gaps related to water security in the specific context of climate adaptation? And what do you think needs to be done to improve the current situation?
I mean, I can't speak for the whole world, but something I have seen where I have worked. I've worked in California, I've worked in Iran, and some other parts of the Middle East, and also parts of Europe. Surprisingly, a lot of times the issue comes down to water accounting. We have collected the data, but what's missing is putting the data together in an equation which makes sense. Unless we we do a proper job of water accounting and understanding where water is headed, headed and where it's going. And if we don't, unless we have a right mass balance equation in place with all the components captured, it's really, really hard to manage water. We often say that stakeholders and water users can live with the lack of water and water shortage, but they can't live with the feeling of unfairness and the lack of transparency. So many governments have this issue. They cannot convince the users that there is no enough water in the system, and because they can't report who's getting what and how water is being lost in the system. So I think this issue is a fundamental problem that we have, and we have not been able to connect the dots in many cases. And I think it's very, very important if you want to do any sort of conflict resolution, if it wants to make sure that we for a long term, we can keep a system resilient and secure. We got to pay attention to this.
Thank you, Kaveh. We have our other two panelists, Kim and Gerald here. So I would put forward you a question to both of you, and that question is to be answered by, or to be kind of responded by both of you, that based on what you have presented, how this data science, artificial intelligence can really help improving water management so that we improve the water security. So you have to reflect on your experiences and tell us something which really doable by practitioners, not from only from research perspective, but how can we bring it to the practice level? Yeah. So maybe Kim, you want to go first?
Okay. So I think well, I'm not a practitioner, so still I have to say something as a kind of scientist, researcher. Yeah. But I think there are two major things are missing to apply scientific assets, scientific resource for real social problems. Is the first one is still we do not have kind of comprehensive integrated assessment for climate, water, food, energy, like multi-sectoral nexus things. So, and to do that, the other missing is we do not have enough data and then not enough exercise to convert some scientific unit into monetary unit. So if we have those kind of components, I think we could apply those kind of the modeling framework to optimization of the allocation of the resources to different sectors, which means in the other way, if there is a deficit or damage or loss, and that can be also converted into some value in different sectors.
Yeah. Gerald, your views?
Yeah. Well, I have worked in machine learning and AI in different areas, so I think we are already quite advanced. There are many tools in society that are coming to, in fact, from the business point of view, from marketing, from from all these big Amazon, IBM. Right now we have GPT-3 that in fact fakes a person. You can talk to it and it's very difficult for you to identify that it's not a human. You have technology that generates images from thousands of hundreds of millions of images. You can detect all type of patterns that we as human beings cannot detect, but if you have a video, you just can detect things that even you randomly are doing without really knowing. So the technologies there, types of data are appearing from proxy type of systems, sensing all type of information. So I believe this COVID-19 last 2 years have sparked the technology exponentially. So it's just a matter of time how we as scientists start to use all these large amount of technology in our own daily life, and it will come that to society back.
Thank you, Gerald. To Alex, you have presented this complexity, right? And complexity gradient. Now, what is your advice to the variety of stakeholders, from the researchers to practitioners and policymakers? You have hinted something in your presentation. Can you elaborate it in 1 or 2 minutes more, please?
Sure. So I think to most scientists, it's really this opening up to working in a transdisciplinary way, and I think it's happening. This is really starting to happen, maybe for 10 years now. But there's still, I think the majority of scientists goes out, develops or learns something about a certain methodology and tries to apply this method in different contexts, and with that having impact. And that might be very water-centric or very energy-centric or very food-centric or very, social science-centric. And I think what we need to do more from a science perspective is to, really wake up and to become much more transdisciplinary. And on the policy side, it's equally sort of to become more open to think about cross-sector coordination. And this is also starting to happen. I mean, more and more governments, especially because of the SDGs, and Javier was hinting at it, to reach the 17 goals, there's lots of trade-offs between them. And I think more and more governments are waking up to the point that they have to strengthen the cross-sector coordination, because if one sector like energy pulls it into its direction, it might actually create really huge losses in other sectors. So both sides have to, so science and policy, they have to go hand in hand. And so other stakeholders like, other international organizations, to improve water security, but at the same time, also allow, other SDGs to be achieved. Thanks.
Yeah, thank you, Alex. And I think you have given me a good question for Professor Edel. You said international organizations, right? I would like to ask Edel, from your perspective, how do you see this role of international organizations and UN system particularly, and universities? What they should be doing, what should be their priorities in terms of, we move towards enhancing water security, especially in the context of this changing climate. Professor Edel,
thank you so much. So I see three points. The first is international organizations like the UN are really embedded in international networks, and bringing together communities, I think, is really key. Like when we talk about climate change and water security, and we saw it during COP, the different divides between North and South, but also what was already mentioned between different disciplines, between policy and science. I think this is a big task for the United Nations and in general international organizations. Second, and this is what was stressed by our Secretary General during the Summit for Transforming Education, it's lifelong learning, and to focus on lifelong learning. And I think we even need a system that forces people to lifelong learning, because otherwise, and this is something we observe, for example, in construction, engineers and architects very often still use the material they used during their study times. And it takes 30 years. There are studies, it takes really one generation until you have a change. So second point is lifelong learning. And sorry for my voice. And the third point is especially for the university part, I think there is a big need to move from mere publication focus in science, impact factor, H index, and so on, to impact orientation. And this is actually why I decided to go to United Nations University, because we have this mission of policy impact from the outset. And I think this is very important that already during your study time, during your doctorate degree, as a senior researcher, you connect to the local questions, to policymakers from the outset. And we should not only produce something and then disseminate, and no one is interested, no one understands. So these are my 3 points again: bridging the gaps, focusing on lifelong learning, and focusing on impact.
So thank you very much for this answer, Edel. We now have time for approximately 1 to maximum 2 questions. The first question would be here from the audience. Does anyone have a question? And I see a first hand raised.
Hi, this question is for Dr. Corso. Great showcase of machine learning NLP techniques, I think, from Nigeria and from Vietnam. I just wanted to quickly ask you, how did, first of all, did you use NLP in the 2 use cases that you showed? And secondly, how is its performance? Because for English, it works sort of okay, I guess, but for other languages, it's still a big challenge, I think.
Thank you very much for the question. Yeah, in fact, NLP has that problem with the language. We did everything in English. We had to do some translations beforehand for the training system. But in fact, 3 weeks ago, I was in Vietnam with the IE National Commission, and they have already developed their own semantic systems for Vietnamese. So I think that's also already there. And in terms of the accuracy, these systems are highly dependent on the amount of information that you have for the training. For the system in Nigeria, we were a little bit limited, but we had experience where we managed to get information from the web in Bolivia, from NGOs, newspapers, all type of organizations. All this information was captured, and we managed to make replicas of some things that make quite high performance, let's say.
Thank you. Lars? No, other side.
Thank you very much. Fascinating topics, but also very complicated. And I would like to follow up on your question, Mukan. No, it's about the role of academia, no, in this, because we often collect a lot of data. We also have a reflex almost to say, okay, we are offering a database, we are collecting data, we are analyzing data, so creating knowledge hubs at universities. No, at the same time, I think the data is collected, it's very costly, it has owners, it has ownership, it has also protection, and it's stored in thousands of databases that exist. No? So isn't it much more the question, how can we have access to that data, which is in some regions with the Freedom of Information Act, etc., or an environment, transparency and so on happening, but it's still at the very beginning. So creating federated databases rather than creating new databases. No? So who could, or how could the university play a role in achieving this, or in accelerating that process? We have discussions at the geodata infrastructure in North Rhine-Westphalia, a state under the national level, and it's so complicated to achieve that. But I think that is the way to go, to provide at the end access to data at the local level where decisions need to be taken.
Maybe
what is the role of university? That is a question. What can
maybe Kaveh and Edel would like to respond. Kaveh first.
Yeah, I think Kaveh can explain what we plan with our 8 program. I think that's would be a wonderful fit.
Yeah, I can. I don't think it was a question. It was a valid comment. So digital divide is a major issue, and at least the United Nations has been continuously talking about this. Our unequal access level to data is also an issue. In some parts of the world, the resolution of data is much stronger and better. But we also, as was mentioned, data ownership is an issue. Data is also being traded these days. So the future, and it's an unregulated market, let's say, and this is quite frightening. So the future is a bit unclear. In academia, we can advocate for free access to data and fair access to data. That's at least in principle. We can fight for that. What we are doing here, indeed, actually, is that we said the same thing at the United Nations. Our decision was not to collect data, not to replicate the existing data, but try to act as a hub which essentially promotes what's out there and makes it accessible to people. It brings the components necessary to address a problem together to understand the gaps, what is missing. And I can't agree more that when it comes to especially water management, but this is true about other sectors, local data matters, and local information and local wisdom matters. It becomes challenging, especially when the global north researchers don't dismiss a lot of facts on the ground in the global south. I don't think by sensing and devices of data collection we can necessarily address that. What we can do is further communications and interaction. But I think I can't agree more with the person who asked the question.
So thank you very much for the answer, Kaveh, and we are now coming close to.
There was one more question.
One more question.
Very brief, very quick. 1 minute.
I have one question from Dr. Keral. Actually, you show one slide that you use the AI for missing variables. So, it was really working for you? I asking you from you, yeah.
For missing variables, there are 2 types of things that we could do. This artificial intelligence with having direct measurements where you can fill in missing data, but what I was talking about was trying to interpret information. Like, for example, there are no databases about floods in certain parts of the world. We did some experiments in the Mekong trying to find also extraction of data from different newspapers and magazines, identifying the time and the moment where the news were talking about the extensions, volumes, and so on. So you can extract indirect measurements to fill in information about events and so on. I don't know if this answers. One is highly technical from measurements devices, and the other one is indirect measurements that help you to compare from people, from citizens, and from other type of information. Yeah. Thank you.
So I would like to thank firstly all our speakers and panelists and those who asked questions in this session. As we are running out of time, we now need to come to a very short summary and conclusion. And firstly, I would like to thank our speakers to thinking beyond what is the common practice in the field of water sustainability research. Kaveh pointed out that we are at the start of the 4th industrial revolution that leads to cyber-physical systems, and I think we have seen some good examples how this can in practice look like. We had, for example, in the presentation by Hyung-Jun Kim, the Meta-Earth concept, building a building a digital twin of the Earth. And this shows us, of course, if we think about the many subsystems that our planet has, that this is a very complex thing. We had, on the other hand, artificial intelligence chatbots used for the assessment of flood risks, for giving forecasts and warning. So we see that the ways that we collect and that we process information is rapidly changing. But all the information that we collect in the end needs to be analyzed and interpreted. And as Edel rightly mentioned, when we do research, in the end connect to policymakers to ensure that there is an impact. But Alex then informed us that we have this policy conundrum that the more complex things are, the more maybe policy relevant they are, but at the same time, the harder it is really to generate an impact. And when we look at all this, I think the message of lifelong learning that was told is one that is important for all of us, that no matter if we are on the side of the sciences or of decision and policy making, that we learn to know more about the advancement of technologies, but also how to handle very complex information that sometimes we can no longer fully understand ourselves. So when we think of artificial intelligence, not everyone will understand what it does, and that makes it maybe more difficult to accept the outcomes, but we must go this way in the end. I would like to thank all of you for attending this session. Please enjoy the coffee break. I would like to ask the session panelists to remain in the room for a minute for a photograph, and everyone else is now free to start the coffee break. Thank you.